Water. We need it to live. And in North Dakota, we get it in several different ways. From the sky as rain. And from melting snows that feed our rivers. Water also comes to us from ancient underground glacial deposits. We can drill for it, like we do for oil. When North Dakota gets enough water, our wheat fields will be lush and green in the summer. And ripe with harvest in the fall. Our sunflower fields will burst into full bloom for a bountiful oilseed crop. But Mother Nature doesn't always smile on these prairies. She doesn't deliver our water supply on a regular basis. Lack of water can shrivel up all our hopes for nature's blessings. And when there's nothing left to harvest, it can make a man feel pretty helpless. Here's a look at the other side of the hydrologic coin, too much water. Look at the difference when this bridge in Minot becomes the gateway to the rampaging Mouse River, that is. Not enough water, too much water. Both sides of a single problem that North Dakotans have been living with for too many generations. And as our population grows, it becomes vitally important to manage our water supply. Our survival depends on it. Cattleman Raymond Schnell says,
water is going to be the most important thing, the most important item, most important single thing that is needed here to keep our economy on a stable basis. We learned it in agriculture, we learned it in our municipal development, we learned it in just our ordinary living here in southwestern North Dakota. Water is the most important single item for the future of our state.
Schnell should know, for this dam across the Hart River holds the water supply for his hometown, Dickinson, a western city of about 17,000. When the 1980 rainfall dropped below average, the city water supply was threatened, and just when the local economy was exploding due to new oil discoveries. An expanding population and a dwindling water supply are not compatible. But only 50 miles away is a great man-made storehouse of quality water. It's so big one can sail for days and not see the same shoreline. It's possible to tour the colorful Badlands and for a moment get close to a cormorant nesting place. It's a great water resource, the Missouri River and the 200-mile Lake Sakakawea, backed up by Garrison Dam. This dam holds back the water supply of the mighty Missouri and is also a source of electrical power, hydroelectricity, not dependent on dwindling supplies of fossil fuel, but on water, a renewable energy source. The Missouri River is the principal artery of North Dakota's water supply. And people like Andy Mark, who live along its banks, can practically feel its pulse.
On the banks of the Missouri, we're again reminded of what a important natural resources is to North Dakota. In fact, many of us think it's probably our most important resource. Over 85% of the water that flows in North Dakota rivers flows in this Missouri. And it seems to be important in North Dakota that we make maximum use of this valuable resource.
You might liken our water supply to a herd of horses, wild and untamed in nature. Only when their energies are harnessed are they most useful to mankind. You might also liken our water supply to a rich golden treasure, a precious gift from nature, not to be squandered. a resource we can and must learn to manage. Historically, North Dakotans have depended a great deal on Mother Nature for our water supply. Today, if you look closely at farm windmills, you'll see that many of them are relics of the past. This windmill, which once methodically lifted water from underground sources, now turns aimlessly, replaced by an electric motor. The early Northwest immigrants chose their farm and village sites as close to a water supply as possible. Because the pioneers' water demands were nominal, it wasn't difficult to dig a well that held an adequate supply, although water quality was sometimes a severe problem. As the towns grew, water needs expanded. One example, fire protection. In 1893, most of downtown Fargo burned to the ground. There was too little water to quench the fire in its early stages. While water shortages were one problem, oversupply was another. Here's Fargo in the spring of 1897, 4 years after the big fire. The Red River had overflowed its banks, as wide as 30 miles in some places. The streets of Fargo looked like Venice. Boat travel was the only way to get about. The city streets, paved with wooden blocks, literally floated away. The threat of flood was faced every spring, and little could be done to control the ravaging waters. Over and over again, Fargo was underwater, as the Red River, like others in the state, continued to flood sporadically. Citizens worked day and night building dikes out of hundreds of thousands of sandbags to avert the oncoming disaster. Sometimes a wall of sandbags did protect the homes from the swollen river. But in many cases, these hastily constructed dikes were built in vain. Many residents of the floodplain simply couldn't afford to do anything but temporarily relinquish their homes to the risen river. A heartbreaking and costly experience. The periodic flooding cost the city of Fargo countless millions of dollars. Clearly, the need for some kind of floodplain management was becoming painfully apparent. Periodic, uncontrolled floods were not only causing a lot of trouble for the city people, they were ravaging our farmland, destroying our food supplies, and sending our irreplaceable topsoil right down the drain. Bismarck, North Dakota is the headquarters for the North Dakota State Water Commission, which holds the responsibility for the state's water management. It's a complex, multifaceted, and demanding job. The engineers, planners, and scientists try to keep tabs on our state's water supply to provide water management and control. State Engineer Vernon Fay talks about some of the problems encountered with flood planning.
A typical example of the complexities of planning is that related to management of our floodplains. There are some very basic differences in the feeling of people regarding floodplain management. There are certain people who believe that structural solutions, dams, dikes, are the answer to providing safety in the floodplains. However, there are just as many people who believe that non-structural solutions, floodplain evacuation, control of construction in floodplains, ordinances related to the uses of floodplains, there are many people who believe this is the way to solve the flooding in some of our river valleys.
This dike, constructed in Grand Forks, is a good example of structural as well as non-structural solutions. Homes were relocated and the floodplain was converted into a park area. As Grand Forks Mayor Bud Westman tells it,
as you can see from the top of the dike here, as we look down over the area, and you can see the park area that is really a floodway. Ordinarily, the river, as it is now, is down low, well within its banks. However, at the time of flood, the water is right up and in 1979 came right up near to the top of the dike that we're standing on now. But in a preponderance of the time throughout the year, and sometimes 2 to 3 years running without any great flooding problems, this whole area can be used as a park and works out very well.
Dams and dikes have uses other than flood control. This is the Yangtoni Dam near Wilton. Its purpose is for recreation and management of surface water. The Water Commission has the responsibility of checking these impoundments regularly for the safety of downstream residents, part of surface water management. Hundreds of older dams throughout the state show wear and tear over the years, and most are repairable if caught in time. But occasionally, massive rebuild projects like this at Epping are required to keep a dam viable and safe. Surface water management includes issuing permits for many small stock dams in farm pastures. A dependable supply of good quality water is an important consideration for plant location and construction. Multiple-use structures like the Jamestown Dam also help protect cities and farms from flooding and provide recreation for thousands of fishermen and boating enthusiasts. In Minot, newly constructed dikes help to protect that city from periodic flooding from the Mouse River, but there had been little prior planning for floods in Minot. This river was already on the rise in a spasmodic spring flood when work was started on the dikes, so it was a race against time. There was no such protection in rural areas. The rampaging Mouse River caused no end of heartaches and expense, a terrible waste of our valuable cropland. In order to manage this surface water, we must plan for the future.
Over the years, we have many times heard officials state, let's stop planning and begin construction. This is indicative of a basic philosophical difference that exists among many areas of our community regarding the value of planning. There are some reasons why these philosophical differences exist. Principal among them, in my opinion, is the conflict between nature and man. Nature has created natural boundaries, which we call hydrologic boundaries, and man has superimposed over those boundaries counties, townships, and in some instances, state lines, and this leads to conflict in the planning process.
It's easier to understand North Dakota's hydrologic boundaries if we first examine the 3 physiographic areas of the state. In the east is the flat and fertile Red River Valley, a prehistoric lake bed. The second area is the Drift Prairie, a glaciated upland characterized by gently rolling hills and dotted with the prairie potholes of the Central Waterfowl Flyway. This region is one of the greatest duck-producing areas in the United States. It's a marsh area that is a superb water resource. From the air, the color of the water says a lot about the quality of the water. There are many alkaline lakes and ponds in the Drift Prairie that also are home for wildlife. The Drift Prairie is also the great wheat-producing section of North Dakota, and it terminates at the Missouri Escarpment, which marks the eastern edge of the Great Plains. Westward is the area of the Missouri Plateau, locally called the Slope. The Slope area is noted for 2 things: grassland cattle production and the Little Missouri River Badlands. This colorful and scenic area was carved by the action of wind, rain, and the river itself. The Missouri, along with the James River, drains into the Gulf of Mexico, while the Mouse and Red flow into Hudson Bay. One glacial geographic feature, the Devil's Lake subbasin, surrounds a body of water which doesn't empty into any river drainage system. So in extended periods of low snow and rainfall runoff, evaporation drops the lake level and the water increases in salinity. In periods of high runoff, the lake acts as a catch basin and its level rises. Higher water lowers the salinity index of the lake, improving its water quality. Fresh water also raises the fishery potential. Gordon Berg and Robert Whitney are two knowledgeable Devil's Lake area residents. They're looking over the hydro controls of a dike called Channel A, which was created to alleviate their lake's flooding problems.
When we talk about the Devil's Lake Basin, we're talking about one of the most complex watershed basins in North Dakota, and probably one of the most complex in the United States. The reason for the complexity, of course, is the topography is flat, and it's a closed basin. And that has a lot of bearing on what the lake level is today. Is that right?
Yes, I think this is right. What we have to take a look at it when we plan for the Devil's Lake Basin is we have to take a look at the 100-year wet and dry cycle. Devil's Lake, I believe, was dry about 1600, and around 1700 it was full. And around 1800 again it was dry. And around 1870, that's when our first records were. It shows the Devil's Lake was at one of its highest marks again. And then by 1940, it was dry again. Then we went into a little wetter cycle again, which we're in now, and it's at elevation 1425 today, which is about 25 feet higher than it was back in 1940. I believe that we will be in this here cycle, wet cycle, for maybe another 10 years. Then we'll be going into a dry, a little warmer cycle again, and Devil's Lake will go dry.
The present level of Devil's Lake is 1425, if I remember correctly. And through the history of that lake, of course, has been up and down the last 100 years. In the present time, and I think the real need for planning is the fact that we don't know if that lake is going to go up, we don't know if it's going to go down. So there's a real definite need for planning in that basin. There's a definite need somehow to get and maintain fresh water in that lake. There's a definite need for an outlet to that lake. And these are the things that really have to be studied.
In order to study North Dakota's water problems, let's see where its water supply comes from. Rivers flow it in from all directions. Much of it comes to us airborne, wisps of moisture scudding along with the wind. The clouds that float over North Dakota are actually evaporated seawater from the Pacific Ocean and the Gulf of Mexico. Billions of gallons of water are in the air at any one moment. In the northern hemisphere, the cyclonic winds travel from west to east, so the Pacific Ocean moisture floats in an easterly direction towards the Rocky Mountains. The Rockies wring most of the moisture out of the eastbound winds, leaving the air relatively dry. For the most part, Gulf of Mexico vapor is not subject to the wringer effect of the mountains, so the Gulf is the primary source of rainfall for North Dakota. When the warm, moist air from the Gulf meets colder air from the northern latitudes, a frontal system usually develops and it can rain or snow. The water supply of the earth is constantly being reused in a beautifully balanced, endless cycle, from the sea back to the sea. All this is called the hydrologic cycle, and if it were not for this phenomenon, North Dakota would probably look like this. The average rainfall in the United States is 30 inches a year. In sub-arid North Dakota, it ranges from 13 inches in the west to 18 to 20 in the east. Luckily, 75% of the total falls during the critical growing season, April till September. Here's an example of the third component of North Dakota's water supply. From water-bearing beds of earth, gravel, or porous stone, called aquifers. The water coming from this underground source was placed there thousands of years ago by the advancing ice sheet, which once covered the drift prairies. This hydrologist is sampling water from a test well, which has been drilled into an aquifer. These tests will determine the quality and quantity of the water in the aquifer. Aquifers contribute 47%, almost half, of our total water supply. A cross-section of this land would reveal first topsoil, then clay layers, an aquifer containing water from the Ice Age, and at the bottom, bedrock. A map of the state's known aquifers looks like this. This mapping is not yet completed. As part of its groundwater management program, the State Water Commission employs contractors to drill hundreds of test wells each year. Continuously samples the cuttings at 5-foot intervals. A representative of the state engineer classifies the samples and bags them for later study. When the test hole has reached the desired depth, the drill bit is removed and an electric logging operation is performed. The electric probe can distinguish each layer, telling clay from gravel, by measuring the conductivity of the soil. A plastic pipe is inserted into some of the test holes to monitor water level and quality. Year-round, the water level in each of the observation wells is measured, and occasionally a sample is taken. At the State Water Commission laboratory, the samples are analyzed and charted. Tests are conducted to discover the mineral content, salinity, and quality of the groundwater. Good water resource management is a direct result of long-term planning.
Good planning does pay off. In North Dakota, over the last 7 or 8 years, we've had a tremendous increase in the number of acres put under irrigation. This has been done from a very limited resource and was made possible because of a very extensive planning effort. North Dakota excels among the western states in the way it manages its groundwater resources. Without this detailed planning, irrigation as we see it today, and as we see it increasing today, would not be possible. Another example of planning that has paid off relates to the Rose Coulee or Cheyenne Diversion Scheme, which is a plan to satisfy Fargo's water needs in times of drought.
Bill Corwin explains.
What we are observing here is known as Cheyenne Diversion. And this was in 1976 and part of 1977 the sole source of water for the city of Fargo and about 60% of the supply for the city of Moorhead. This water originates primarily from Bald Hill Reservoir and is augmented downstream by flows from the Little Yellowstone Springs and from the sand hills south of here. This water, as it comes down the Cheyenne, is stopped by this dam and in turn pumped through this pumping house on the east side of the river into what is known as Rose Coulee. Rose Coulee meanders eastward, eventually goes into the Red River, and in turn is picked up by the filtration plants of both cities.
This plan has been used only once, but it was used at the time when the Red River was practically dry and Fargo desperately needed water. We channel the water from the Cheyenne River through the Rose Coulee and into the intake system of the city of Fargo so that it could satisfy the needs of its citizens. Planning does pay.
Water resource planning tries to answer questions of this type. Can a sewage disposal system handle a growing population? Will water supplies be adequate for incoming industry? Can the installation of a rural water system solve water quality problems? What effects will the continuing use of farm chemicals have on aquifers, lakes, and streams? we augment present water supplies when the demand exceeds the supply? These are just a few of the questions.
Although we do have limited areas of water supply throughout the eastern two-thirds of our state, the most valuable resource that we have for satisfying the needs of our citizens is the great Missouri River. The increasing demands for water downstream makes it imperative that this state develop good plans that can be implemented to take water from the Missouri to serve the needs of the people throughout the state.
The source of the Missouri River, so important to our state's water supply, begins high in the Montana and Wyoming mountains. It's a collection of water from the Bighorn, the Powder, the Yellowstone, and many, many smaller tributaries. More Missouri River water flows out of North Dakota than flows in.
Many other states are jealous of this important resource that North Dakota has, and perhaps will make use of it for themselves in the future if we don't reserve it for our use. So I believe it remains one of the most critical things that North Dakota must do in the near future so that we don't lose this precious resource.
When I'm talking about a good plan, I mean a plan that has been formulated by the people at the grassroots, where people participate in helping us decide what should go into the plan, what should its results be. I don't believe I can stress too much the need for this local participation in our planning process. If we are to satisfy the long-range needs of our people, if we are to claim the waters rightfully ours from the Missouri River, we need grassroots participation, and that is the focus of our planning effort. In North Dakota, there are times when large areas of our state and many of its streams are dry for long periods of time. And in other parts of our state, we have ample quantities of water. So it is safe to say that in North Dakota, we do not lack water, we lack a distribution system. And planning becomes particularly important when we visualize taking water from the western part of our state to satisfy the needs in the arid areas that exist in the remainder of the state.
Water is a very interesting substance. It covers most of our world, and the original supply is all we've got. We keep using it over and over again. All living creatures depend on it for life. We drink it. We swim in it. We ski on it. Fish in it. Paddle in it. Have a good time in it. People travel long distances just to be near it. It's a prime source of recreation. Water is the golden treasure for our future, a precious gift from nature, not to be squandered. And planning beginning at the grassroots level will unlock this storehouse of benefits that water will bring to the great state of North Dakota.